Hello, everybody. My name is Michael Farnum, CTO at Set Solutions, here to talk to you today with 42 Crunch on the benefits of a positive security model for APIs. So as I said, I'm CTO at Set Solutions, and we've got Colin Domoney here with 42 Crunch, developer advocate. Colin, do you want to introduce yourself to the group?
Yeah, certainly. Good morning, good afternoon to attendees joining, and great to be speaking to you today, Michael. Looking forward to this. So I'm a developer advocate and API security research specialist at 42 Crunch, and I also curate the weekly API security.io newsletter, where we cover all things API security.
Thank you very much. Colin is being a little humble. He's got a ton of experience. I'm very excited to be speaking with him here on the positive security model and also about API security, very important topic. So for anyone who is joining today, we absolutely encourage questions. So please use the Q&A panel. So let's get started. So the main points we'll talk about today, this is not an agenda slide. This is what we'll be covering and kind of interspersing throughout the whole webinar. As you see, kind of the grayish undertone of the left side and the kind of the brighter pastel-y colors on the right side, they're kind of done that way on purpose because we'll talk about AppSec tooling and the negative security model. I don't mean to say that the negative security model is a bad thing, and Colin, I think, will agree with that. It's just a different way of doing it. You need to do a lot of different things to secure your environment, but we're here to talk about the benefits of a positive security model, and specifically in APIs, and how we see that and how 42 Crunch can help solve that. Here to talk about the age-old issue of the issues between security and the development teams. We'll get into that in a little bit, but Colin and I come from two different worlds, and I think we offer the benefit of being able to see it from both sides. And then, as Colin's title suggests, he really likes creating the empathy for the developer, and I've come around to that conclusion a long time ago as well. And I think it's a thing we have to do to come together and be able to secure our applications, and specifically our APIs. And then we'll talk about that frustration that the developers have over the years, and then how do we reduce that frustration and that fatigue to make them more productive, and how we can come together more as a team than opposing sides to a problem. So to dig into that developer frustration and fatigue, like I mentioned, I come more from the network and security side of the world. And as a lot of people know, there tends to be from that side, developers don't want to fix anything on the security side. They just want to do their job and not worry about the security piece of the equation. And so the old department of no on the security side gets frustrated with them. Developers get frustrated. They have fatigue. We'll talk about it in more depth here, specifically for APIs, but the security tooling that gets put in place for figuring out what is the problem, what are some of the flaws in the application, security flaws specifically. That tends to be a ton of data to the developers, and it just leads to a lot of frustration and fatigue. And it's been that way for application security for Colin, since we started writing applications, I would imagine. What do you think about that?
Yeah, I mean, pretty much. And I think maybe some color to my background is I come from, I've got a great job at the moment, developer advocate. It's something I love doing, because although the latter part of my career has been as a security guy, I actually come from a development background. I used to, design embedded systems and electronic circuit boards and the like in the early part of my career. So I do think like a developer. I like being creative and I like solving problems. But obviously, I've been on the other side of that fence. So I'm, I've got a relatively unique perspective on both sides of that problem. And I think the patterns that we see, you mentioned we've how long have we been doing AppSec? Over 2 decades now, 2.5 decades we've been doing AppSec. The same topics come up, the same frustrations, the same gripes and complaints, and now we're talking about API security as a standalone category. We're getting exactly those same topics coming up. Developers are frustrated with the tooling, with the experience that they have with security tools, and in particular, they get frustrated when security teams don't have that empathy. And I think that empathy is really important. And having a foot in both camps is a huge advantage.
Yeah, I 100% agree. I spent several years at a application security vendor after doing pure security for a long time, and I learned to develop some of that empathy while I was there. Learned that we have to speak to them and work with them. It can't be against each other and at odds. So I really appreciate also the fact that anytime I've seen a developer come into the security field, it brings more of that empathy. So I appreciate your background and your perspective there. It helps tremendously. So you mentioned, though, that we have the traditional web security, and now we've got API security, which is even different. So this is the OWASP top 10 for the traditional top 10 that everybody kind of knows and maybe loves on the right side. Yeah. And then on the left, you've got the API security top 10, very specific to APIs. And you can see that there are a lot of differences between the two. Some of them, there's definitely overlap. Some of the same issues plague both, but there are quite a bit of differences in there. So now that we've already got the frustration with web security, and as you mentioned, you add the API side of it, which is definitely different in many ways than just traditional web application development. So there are differences there. Do you want to talk to any of that? Or?
Yeah, I mean, this is probably one of the controversial topics that comes up when we talk API security. Is people definitely have that web security mindset. The OWASP organization has done a great job of highlighting those issues. I think everybody now knows what SQL injection is, or OS command injection, or cross-site scripting, or any of these issues that are predominantly web application security topics. And I think APIs are different. They're different in the nature of, obviously how they're designed and how they interface. APIs now, I mean, there's a couple of, this question of pessimist to optimist. If I wanted to be pessimistic about API security, I'd say that, it is challenging because the APIs are now where the data is stored, right? The attackers have got wise to this. They know that they're not going to bother attacking the web app or the mobile app. They'll just go after the backing API, right? So APIs are increasingly under attack. We've also got issues that APIs are obviously almost by design are going to be public in some way, right? So they're exposed. They're also well documented. So we've got a couple of these things sort of colliding together to make APIs, really a high risk category. I've heard proponents of web application security vendors and people who've worked in web security saying that they're just the same thing. Well, they're not really. We take BOLA, broken object level authorization. It's number one on the API security list there. Basically that's, the most prevalent and also the highest impact API vulnerability. And basically what happens here is you're able to, across the API, access objects, so broken object level. So in other words, data belonging to a user that you don't have rights to. So imagine if you're logging onto Gmail, you're wanting to read your email, you can tamper with the parameter and you suddenly can see somebody else's mailbox, right? That's what BOLA looks like on a web app, right? So that's a completely new category of issue. We've also got the API 3 and API 6, which are your data vulnerabilities. These are where your API returns too much data, so it leaks PII information. And we've got mass assignment, which is the inverse of that, where your API accepts input data that it shouldn't, and it commits that or persists that to a database. So entirely different types of vulnerabilities. What does this mean for developers? So firstly, it means that, they need to be aware that the APIs are being attacked in a different way, and that some of the defenses that they might have used before don't work. But I think really for the security teams, this means that, there has to be quite a seismic change in the way that they approach API security. So that's the pessimistic view, and we'll talk when we talk about the positive security model, why I think we actually uniquely poised with API security. We've got a tremendous opportunity in front of us.
Mhm. Well, I mean, I think that's a great segue to talk about what we talked about before, which is the tooling. So the tooling was already an issue when it came to API security or to traditional web security, and just the way that we approached it with SAST and DAST and different tools. WAF, putting WAFs in early on in my career when I was selling WAFs, some of the first ones, when you had applications that weren't really dynamic in any nature. They were fairly static, very few changes. APIs generally by nature are fairly dynamic and changing. People are developing directly to that, and I don't know how many times I hear a week that we have an API first approach, and that's what we're developing on. And there's going to be quite a few changes of that happening from a development side over and over and over again. You can't keep up with that, the traditional WAF. SAST is definitely not designed for the APIs. They're too complex, and it can take a really long time. Coming from a vendor that did SAST and DAST testing, the APIs were the bane of our existence in many cases, and we couldn't get the results over in time, and it caused a lot of frustration with the developer teams and the security teams that we were talking to, because they would leak that frustration over to us, because the developers they have timelines, they have to get stuff through, and the traditional toolings just does not keep up with that.
Yeah, and I think from my perspective, that's an article that I wrote. I'll actually pop that article, the link in the chat window in a mo. But I come from a background of primarily SAST and a bit of DAST. The technology is good. I'm not knocking what SAST has done for the industry. I think it's when I started in the SAST was hardly used, and now it's pretty much mainstream. There's probably no organization that isn't using SAST or DAST in some combination. But I think just a note of warning here is that SAST wasn't really designed for API-centric applications. So to give context there, a lot of SAST is looking for ingress points that you would find in a web application. So it's looking for a form submission, or it's looking for data fields in Java service pages and the like. And it doesn't know how to interpret an API endpoint, right? So if it doesn't know where the input is, it's going to be very hard for it to build that internal model. And then we tend to have that issue with SAST, and with, well, SAST is characterized by quite high false positive rates. And it gets worse for APIs, because not only are you getting high false positives, but the tool isn't useful. It's not finding things, right? So you tend to end up with quite a lot of noise with low value. So you're giving the developer the worst of both worlds. You're not helping them, you're not adding value, but you're making unplanned and in many cases unnecessary work.
Agreed. DAST is one that also I've found, talking to some of my customers, not only just DAST, but even knowing that an API is out there, being able to use traditional security tools to find what they can integrate with. They're not there either. I do think that SCA is still extremely useful in this case, because it can find a lot of components that have problems, but I agree, it's not the end all be all. That a lot of people honestly touted SCA when it first came out, when they first started doing it. It was like, oh, we're going to fix all of the things with the components, and it doesn't necessarily match that. So
yeah, I think SCA, my point of view on SCA is it's just table stakes. It's just something you've got to do. It's hygiene. It's easy to run. It's cheap. There's free tools. Just do it. There's no reason not to do that. And then, of course, now the whole software bill of materials is a hot topic, and I think that's going to become more and more important as as our supply chains become more complex. Right, we're ingesting more risk, more vectors for vulnerabilities, and knowing what you're building and having an inventory of that, and knowing the provenance. I think that's going to be a big focus area now on the tools.
Agreed. So I think the conclusion overall is that all of these tools have their place. They've been in place for a long time. They've all added value in some way, shape, or form. Some of the new WAF tooling out there, the next gen, if you want to call it, has its place as well. But a lot of that still works from a negative security model. And I think what we want to talk through is more of that positive security model versus the negative model. So Colin, if you want to run through this, I think this is a very important slide that you've put together that we're using here to talk about how there's the allow list versus the block list, positive versus negative.
Okay, so let's, Mr. Pessimist here is going to start on the negative model. That's the block list approach on the right-hand side. This is the way we're used to doing things with the tools, and I'm thinking of, predominantly web application firewalls, any kind of proxying or inline filtering, and even some of your code converters that you use in for input validation or output encoding. And what these things do is they work on a model of, that one line there summarizes that they attempt to block known bad. So they're trying to know what bad looks like. So take the trivial example of a SQL injection. Everybody knows what that looks like. It looks like a comment sequence and an escape in an initial command. So people can kind of guess what that known bad looks like. The problem is for a block list approach to work, you have to know all of the possible known bad, right? Which is, well, by definition, not possible to know. And even if you do know it, it's possible that clever attackers, and let's just assume that the attackers are probably more clever than many of the defenders. That's a general truism, I think. Attackers can subvert that. They can use things like character encoding. They can use alternate character sets. There's numerous ways, there's books written on how attackers can bypass traditional block list based defenses. Right, so they're easy to subvert, and also, and we take the example of WAFs. You've normally got to tune and get the WAF working. You've got to tweak the rules. You've got to apply different rule sets. It's quite frustrating to deploy, and then of course it's also frustrating because it can misoperate. So when it says it attempts to block known bad, obviously there's a big window there for blocking what is actually good. Right, so you get the false positives and false negatives. I think anybody who's worked with these kind of tools knows this very well, and it's just frustrating to all concerned, from the developers whose app breaks to security people who still have vulnerabilities, right? And they still get breached. So, flipping over now to the positive security model, which is based on an allow list approach. And this is where I said there's some unique advantages of APIs. Because the API is essentially a coding construct that is specifying a contract, right? It is saying, if you've got two microservices that are communicating, or you've got a backend and a mobile app, that API serves as the contract, right? And that is how that backend is going to behave. Right? It's not a user interface where the user may do any number of random combination or sequences of things. The API is really that binding contract. If I give this input, I expect this output, right? And this is what the Open API specification, or what people probably know better as Swagger. It's a human readable machine language specification of the API contract. Right, so it defines the inputs, the methods, the data constructs, the parameters, the expected results. Here's a picture's worth 1,000 words. There's an example bit of Swagger. We've all seen that Swagger UI that allows you to go play around with an API. That API is very well defined. Let's take that last query, the pet ID. What that's saying is that endpoint will respond via GET with a with a pet, given the pet identifier, and that's all that API endpoint will do. No more, no less. Right. So just summarizing the benefit of that allow list, the biggest advantage is that instead of attempting to block known bad, it only allows known good, right? And can we know all the good? Yes, we can, because we know what the data constructs look like. We know what, for example, what the data model for a pet looks like. You know, it would have the type of pet, the number of legs, this kind of thing. That's the data model. That's known, right? So we can fully specify the interaction and the behavior of that API, right? So there's no guessing, right? So rather than trying to understand what bad is going to look like, we know what good looks like. And we talk about the tooling and how we can use this contract to define pretty much the entire downstream operation. And that goes to generating the code, to testing the code, to protecting the code. Right, so that positive security model where we use the contract to define the allow list, and then we base everything off of that. Now, there is one drawback to this, or there's one caveat, and that is you need to know what that contract looks like, right? That's the starting point, and that's why the drive toward API design first is important, and that's a good slide to segue to. Typically, the way developers work is they will start with an open API specification file, and they'll use something like Swagger Gen or open API Gen to generate code. They'll generate that backend code. There's an efficiency for developers there, right? They don't have to write all that code. These tools are very good at taking that definition and generating the code. In other cases, developers already have the code and they have some backend code existing. Swagger and these tools are able to introspect into that code and reverse engineer the OAS file. And then, you know, what we would recommend is that people then take that OAS file. You can also reverse engineer OAS files from network traffic. We've got some activity going on that. So there's ways to get your OAS definition, and then use a DevOps approach to allow, you know, everything is code, right? So your API behavior, your contract, your testing parameters, and everything is driven via that open API contract. Mike, I think just go back to that previous slide, because I just want to summarize the salient points on the on that one. So they define the contract for downstream development, and there's other advantages for developers. There's advantages in efficiencies in the way they can build out their code stubs. They can use fantastic tools like Postman, right, to test the APIs and to do unit testing and integration testing on the APIs. They can use Postman to build mocks and stubs of pieces of the API. So there's security benefits, and we go into those in a bit in a moment. But also there's other benefits to having that design first approach. And then what we can do is, once we have that specification and we're starting to, what do we do? We got pets, so we got a definition for what a pet looks like. So, you know, we can specify in that schema that a pet ID should be an integer, and it should be an int32, and we can constrain that. We can constrain the types of responses we allow. We can constrain the data that we accept, so that we don't accept things that aren't defined. And conversely, we can also ensure that we don't return excessive data. So already there you can see, by using that spec, we already trickling down that list on the OWASP API top 10 of things that we can actually detect and enforce on that contract.
Colin, are you open to take a question at this point, or do you want to?
Yeah,
wait?
let's
So the question for everyone, I'll just read it here, is Gartner has identified API credential theft in 3 of the 4 most common vulnerability paths, API vulnerability paths. The question is, if that's true, is the allow list based on data format, et cetera, still vulnerable to credential theft attacks?
Yeah, the answer there is yes. You know, your credentials are are the keys to the kingdom. I saw Twitter's just been in the news today. Thousands and thousands of access tokens have been leaked. You know, this is one of the categories where we look at that OWASP API top 10, you know, that security misconfiguration. That's not something that's easily detectable with a contract or with that allow list. So that's something and I know we've got a slide on this in a moment, but I'll talk to that when it comes up. But API security is a multi-layered, multifaceted discipline. Right, it's built on multiple foundations, and this idea of credential theft or token theft, this is not unique to APIs, but it's probably more painfully felt with APIs, because once you have a token, especially if you have one that doesn't expire, your API is essentially totally compromised. But the idea of credential theft and token or password theft, this is an age-old problem that, well, I guess is probably going to be with us for some while still. But to that point, no, there's nothing explicitly in the Open API spec that can help you with that. That's really a hygiene and environment and a practice, best practice problem. But thanks for the question.
Yeah, Tom McNamara,
do
thank you very much for that.
Yeah.
Okay.
Right. I think we covered that on the spec, and I'm happy that we've covered that. We come back to the our approach to this in a moment. Yeah, and this is what I was talking about now. So when I think about API security, my approach is, and 42 Crunch, the approach is that it's a multi-layered solution. But there's no silver bullet. There's no one thing that you can drop in at any point that is going to give you perfect API security. It's built on a foundation. So if you don't have a good DevOps practice in place, and if you are relying on manual code deployments and you can't produce repeatable builds of your software, you're going to be in trouble from a security point of view, regardless of what else you do, right? If you're not able to reliably reproduce your software. Also, we'd spoken about the value of things like SAST and DAST for APIs, but all means use those. If you're going to, you might find interesting things. Just be aware of the limitations. By all means, use SCA. Find vulnerable components. It's another attack surface. Most people are running API gateways. They do a very specific job, and they do that job well. API manager and tools, help you manage your access, manage your inventory, also useful. But just bear in mind that there are going to be significant gaps in your security posture. And that's where, obviously, our approach is to have a shift left, shield and protect right combination of the 42 Crunch API security platform. And that will allow you to address the issues that the other solutions don't at the moment. And obviously, the best approach is have that full stack in place, have everything in order, have everything working properly, and then make sure that you've got a good governance process put over the top of that. Right? Why is governance important? Because it's great that you have all these tools in place, the methodologies and the practices, but if your teams aren't adhering to that, then you've wasted that investment. And I think APIs are one of those ones, and Michael had mentioned earlier that the APIs, because they're easy to stand up, because they're easy to implement and host on cloud services, it's very simple to run up an API. These APIs are very prone to shadow IT and development teams doing things that they shouldn't be doing, right? So having your API governance in place is particularly important on APIs. It's more important than it would have been on web applications.
Well, web applications being able to stand up in shadow IT was enough of a problem, but with APIs being the front of the data and getting those stood up very quickly, and the propensity for teams to share that data in different places, and then being able to turn that up, it's an even bigger problem. Absolutely.
Exactly. So the domains of API security, so really following on, I think, quite nicely from the discussion of this multi-faceted, multi-layered approach, is when we've had customers come to us and say, well, how do we get started? What does API security look like? What I've set out to do is take that, the DevSecOps model, the figure of 8, the plan, code, build, test, release, deploy, operate, monitor, and kind of cycle, and then to pull out what to me look like the domains for API security, and then to map those on, so that the colorful diagram, we can see if we're talking API design, we're obviously doing that in the plan stage. So, taking that as an example, what does API design look like? Are you incorporating security into that design phase? Are you looking at your API threat model? Are you understanding your attackers? These are all things that are done, at that extreme left of the design stage. Governance is one of these cross-cutting concerns that's applicable across all 8 cycles. API protection is obviously going to be applicable to operating and monitoring. The idea here really is that right across that spectrum, there's activities that you could and should be doing to improve API security. And I wouldn't, simply having your developers understand how to code secure APIs, if you're not testing that and validating that, you've got a gap in your coverage, right? So for each of those domains, there are a set of activities that look like best practice. And what we're working with organizations to do is give them a kind of roadmap for API security success, because everybody is in a different position when they start this journey towards securing APIs, right? Some people will focus very much on runtime protection. Maybe they're running RASP, or they're using a next-gen web application firewall. Other organizations will focus more on the test side, right? So different organizations, different companies will have different starting points, and they'll have different trajectories, right? Some organizations will favor very rapid development cycles. Other organizations, healthcare, will be highly governed, right? And will want to really stress that governance. So your journey to API security is it's bespoke. It's down to you. There's no one size fits all. There's also no magic, no silver bullet there. It's a practice.
I think I've always think of this as, even though you're bringing all of them together, when you think of the dev, sec, and ops, those are 3 distinct personalities, groups, if you will, within that process that all have to work together, which is the whole focus of DevOps and DevSecOps. And each one of these groups are going to focus on different things within this journey. Absolutely. And again, talking about my background coming from the network side, I would tend to focus on the inventory side, because I would want to know what's floating around in the network. How can I get all of those assets in place? I tended to focus on that a lot as a discovery portion of when I talk about API security. But what a lot of the conversation here is putting those developers into this, is that design stage and that development stage. The developers have to focus on that. Then the security has to focus on the testing and the protection. I mean, these are all pieces that come together. I think it's a great way to look at that, and to say all 3 distinct personalities and teams need to come together here. And then if we're approaching that with developer empathy versus going back to saying, you just need to do what I tell you to do, Mr. or Mrs. Developer, that changes a lot of the attitude.
Yeah, and there's one more thing to highlight on this, that thinking as the optimist again, is that API security has that big advantage here, that we can build that DevSecOps process off the back of the open API definition, right? So if we do our planning right, and we design that API properly, and we fully specify it, a lot of those things can automatically, let me give you pick 2 examples. So your testing, and this will segue into what 42 Crunch do. Your testing stage, you can fully automatically validate that the API that you have intended to build, so your plan, and that you've actually coded and built, matches, right? So have you built the correct thing? And you can do that all with the API contract. Secondly, if you are protecting and operating an API, you can use that API contract to enforce a firewall. So a very precise firewall. So this isn't a firewall that's kind of guessing what known bad looks like. It's a firewall that is based on that open API specification, and it will only allow what is in that contract. So that's 2 things where the definition actually drives the entire downstream process.
Is that the
And
right time to jump to
yeah,
this?
let's talk to this. And I'm aware of Mark's question. I'm going to answer that because we come to that in a moment. So our philosophy, 42 Crunch, our founders have been doing this for longer than I've been doing AppSec. I think a long time. They've got a lot of expertise and APIs, and their approach is shift left, move the conversation, move the security as far left as you can. So as soon as you start designing or writing an API, go and audit that contract. So what we see typically, if folk are using, if developers on this session, if you're using Visual Studio Code, we've got a plugin for that. It's the top plugin in the market for Swagger or for Open API definitions. That will run up that definition, and it will do an audit on it and say, you're deficient. You haven't considered security aspects in these places. You haven't constrained your data. So really being developer friendly, being helpful to developers, and adding value to developers and working right in their environment. And then once we've got that audit in place, then we drive that process downstream. So developing, we are, the solution is super CI/CD friendly. APIs are being built at scale. They're being built rapidly. They're being deployed frequently. If the security tooling is not working in an automated manner and it's not CI/CD or pipeline friendly, it's going to lead to frustration. We've ensured that the solution integrates very well across a number of platforms. We can, assess for vulnerabilities in APIs anywhere in that pipeline. We run quickly. We do the audits. The audits run quickly. We can do scans at any stage. So if a developer's got a desktop instance where they're running the API in a container, we can test that for runtime behavior, or we can test that in production, right through to production. And then finally, with the best will in the world, regardless of how well you've defined and implemented your API, you are still going to have attackers that will get through. We have a firewall, which is the third piece of the puzzle, that enforces API protection at runtime, right? And it does this, dynamically. It's a firewall that's deployed in front of the API service and ingests the Open API definition, and enforces that protection exactly against that specification. I think there's one more slide. Is it
one more slide? Yep.
Yeah, and I think we probably covered that, if I'm honest. So, yeah, what have we got there? Just summarizing there, we've got the audit, which is checking that the wellness, or how well you've defined the API contract, and then obviously all the things that you'd expect to have, like assisted guidance, being able to run scans within IDEs against individual endpoints. That's all possible. And then the protection that we'd spoken about, and then being able to integrate this into the full API lifecycle, right? So the whole process is continuous. We can extract compliance statistics. We can work out changes in APIs, or who did what to APIs. So that's the solution. I'll take that. That's a really great question from Arcanes. So the question is around, what about issues that are not expressed in the specification? And the example given there is Bowler, right? And it's the question of how can a tool or how can a solution prevent against a complex attack vector like Bowler? So, that is one of the issues, because it's not specified in the specification. Bowler is one of those things that can't be, fully automatically protected according to that spec. There's a number of approaches. Obviously, we are working on, solutions in the space. There's other practices and design methodologies that can help address issues like Bowler. There's best practices that people can do. And then the other thing is we do provide a number of extensions to the Open API specification, the vendor-specific extensions. I'll give you the example. We can do things like we have an extension that allows you to enforce rate limiting. So we have a decorator that you can annotate, and obviously when we have solutions around things like Bowler, we are able to extend the specification. But good point. That is one of those that it's a little bit of a corner case there.
I think this next question
this is for you.
me.
Yeah, it is.
So Bruce, thank you very much for leading into that. I realized that I didn't really say what Set Solutions did in the beginning. So Set Solutions is a cybersecurity reseller and integrator. We've got a lot of professional services in place with a lot of application and API specific security experience. So our role in this is to help you figure out the best tool for what you're trying to do, which in this case, we're talking about 42 Crunch and how that affects in the positive security model, how it approaches it from a developer friendly first approach. And our role in that is to help you figure that out, and then to help you potentially integrate that, build your application security program as well. So all of the things that Colin talked about before, all of the different layers, we can help with a lot of that implementation and integration aspects there. We've got a lot of automation and orchestration DevSecOps experience on our staff that can help you build that program out, and implement 42 Crunch into your environment. So that is our role. Thank you for that question. Well, we got another one. Bruce just asked you.
Yep. What sort of authorization works best with 42? Okay. I'm not sure if there is a best on that. So, we do. So just talking about JOTs. So the question is, what sort of things on Bowler 42C? What can we do around authorization and JWT? So we have a full JOT token validation engine. I've got a webinar that I did toward the beginning of the year where we look at that in some detail to fully validate the JOTs. I'm not sure if there's a works best with answer to that. I think that will be a design decision, and then as long as that is specified in the spec, we can validate that JOT in the tooling. And then we have there's also plenty of resources on best practice for JOTs, correct validation, but we have a JOT token validation built into the firewall product. So that and also what we can do is we can inject JOT token policies into the specification as well. Right. So if somebody presents a token that is invalid or not according to the specification, then we will we'll be able to reject that. I'm just grabbing it
into the authorization side that goes beyond just what 42 Crunch is doing. Absolutely.
Yes. So, yeah. We have relationships with identity providers and the like as well. And this just goes further to the point that the API security it's a broad topic. It's conceptually simple, but it's actually a very broad topic.
Honestly, something else. Since Bruce also asked a question about us, we've got identity and access management and identity governance experience. We sell a lot of different tools in that space and can do implementation in identity and access space as well to help you bring that tooling together with how you're getting access in your APIs, how you're authorizing access into those, and keeping your API keys and that kind of thing secret, the vaulting tools. Yep. There's a lot that goes around that. So
yeah, and just that link that's been popped in there, we're doing a second part of a webinar series that's was quite fun and quite entertaining, where we look at people who've organizations who've fallen foul of some of these basic problems. We look at the breaches, we look how they got things wrong, and we look at different ways of protecting against this. So that's next week if people want to learn more. And then obviously the API security.io newsletter. If you're working in API security, that's probably worth worth joining.
I get that newsletter. I enjoy it. It's a lot of great information in there. I've got a weird place in my heart for API security. I'd love to read that and to run up on that. We've also got, as far as Set Solutions goes, we've got several videos in our on our YouTube channel, which is just youtube.com/Set Solutions, where I talk about API security as well. Definitely very important to us and our customers right now. So,
sure. Michael, I think yeah, I think we're done.
Yeah, we've got a
thanks.
link in the chat also that you put in, the apisecurity.io. It's where you can sign up to for the newsletter. And this has been great, Colin. Thank you very much. I really appreciate your time and your expertise and that developer first approach and developing or creating that developer empathy. Anybody who's in security specifically or in the operations side who hasn't developed that empathy, please listen to them. Please try to create that teamwork instead of that those back and forths going after each other. We all got the same goals in mind. So Colin, I appreciate your perspective, appreciate your time. 42 Crunch is a great partner and looking forward to doing more of these with you.
Yeah, thank you very much. It was good to talk.
Thanks everybody.
To the guys for the questions.
All right. Thanks, everybody. Appreciate your time.
Cool. Thank you.